For 12 hours, North Atlantic Ocean, the early morning over the North Atlantic was dark and silent. A powerful U.S. carrier strike group moved steadily across international waters, conducting a scheduled naval exercise with allied forces. Radar systems scanned the horizon while fighter jets remained on standby aboard the carrier's flight deck. Everything appeared routine until the first alert appeared on the radar screens. A sudden signal spike flashed across long-range detection systems. At first, operators believed it might be atmospheric interference or a routine radar reflection. But seconds later, satellite tracking confirmed something far more serious. A missile launch had just occurred. Launch detection infrared warning satellites detected multiple heat signatures rising from a Russian naval vessel operating far beyond the horizon. Within seconds, early warning systems relayed the data to naval command centers. The weapon type was quickly identified. It matched the launch profile of the 3M-22 Zircon, one of Russia's newest and fastest naval weapons. The missile was designed for a single purpose: destroy high V-value naval targets like aircraft carriers. And now tracking systems showed two of them accelerating toward the American fleet. Carrier Strike Group alert aboard the U.S. carrier. Alarms echoed through the Combat Information Center. Crew members rushed to their stations as the fleet moved into defensive posture. Guided missile destroyers surrounding the carrier activated their radar arrays. Electronic warfare teams prepared countermeasures while missile defense crews waited for firing authorization. Within seconds, tracking data showed the incoming objects traveling at extreme velocity. Speed estimates climbed rapidly. Mach 5, Mach 7, possibly faster. Hypersonic weapons left almost no reaction time. Command-notified data from the carrier group streamed directly to United States Navy command centers and strategic monitoring networks. Military analysts quickly calculated possible impact points. The missiles were approaching the fleet's defensive perimeter. At their current speed, they could reach the strike group in just minutes. The challenge was enormous. Hypersonic missiles were designed specifically to defeat traditional naval defenses. They maneuvered unpredictably and traveled faster than most intercept systems were designed to counter. Defensive systems activate. The carrier's escort ships move into a tighter defensive formation. Advanced radar systems locked onto the incoming targets. Launch crews prepared interceptor missiles inside vertical launch systems across the fleet. Electronic warfare teams attempted to disrupt the missile's guidance signals. The ocean remained calm, but inside the command centers of the carrier group, tension surged. Every officer understood the stakes. Aircraft carriers were among the most powerful symbols of American naval power, and destroying one would change global military balance overnight. Hypersonic speed. Confirmed tracking computers updated again. The incoming missiles had accelerated even further. They were now moving at hypersonic velocity, skimming above the ocean's surface while performing unpredictable maneuvers. The time remaining before potential impact was now estimated at less than 4 minutes. Inside the combat center, one officer spoke quietly. Interception window closing. The commander gave a single order: prepare to engage. The interception decision. Across the carrier strike group, missile launch systems were now fully armed. Intercept calculations raced through onboard computers. Destroyers prepared to launch defensive weapons designed to stop incoming threats before they could reach the carrier. But hypersonic weapons were unlike anything the fleet had faced before. Their speed, maneuverability, and low flight path made interception extremely difficult. For a few 10 seconds, the fleet waited. Then the final authorization was transmitted across the network. The United States Navy was about to attempt something rarely tested in real combat: intercept a hypersonic missile in mid-flight seconds from impact. Radar screens showed the two objects closing rapidly, distance shrinking, altitude dropping, trajectory shifting. The missiles were now within the fleet's final defensive layer. Every system on board the destroyers and the carrier was focused on the incoming threat, because in the next few seconds, the fate of the entire carrier strike group could be decided. the defense window inside the Combat Information Center of the Carrier Strike Group. Every screen glowed with urgent data. Two objects were moving toward the fleet at extraordinary speed. The computers identified them as incoming hypersonic threats, matching the profile of the 3M-22 Zircon. These weapons represented a new category of challenge. Traditional missiles followed predictable ballistic paths. Hypersonic weapons did not. They could maneuver, change altitude, shift direction, and travel at speeds that drastically shortened reaction time. For the officers watching the radar screens, the next few minutes would test the limits of modern naval defense. Defensive systems online across the surrounding escort ships systems activated automatically. Guided missile destroyers belonging to the United States Navy brought their radar arrays to full power. Massive phased array antennas scanned the sky and ocean surface simultaneously. These ships formed the protective shield around the carrier, a layered defense system designed specifically to counter missile threats. The ship's computers calculated possible interception opportunities, but hypersonic weapons made the problem far more complicated. Their speed meant that calculations had to update constantly. Even a tiny shift in the missile's path could change the entire interception plan. Calm voices, high stakes. Despite the tension, voices inside the command center remained calm. Training had prepared the crew for exactly this kind of situation. Every officer knew their role. Every operator followed a strict checklist. The fleet commander stood behind the main radar station, observing quietly as specialists worked through the data. Orders were short, clear, precise. There was no time for confusion. The technology race, the confrontation represented something larger than a single naval encounter. Around the world, military planners have been debating the implications of hypersonic weapons for years. These systems promise unprecedented speed and maneuverability. For defenders, that meant far less warning time. For attackers, it meant a higher chance of penetrating traditional missile shields. Both major powers had invested heavily in developing these technologies. The events unfolding over the ocean were a glimpse into that ongoing technological competition. Electronic countermeasures, electronic warfare teams aboard the fleet activated their systems. These specialized units attempted to disrupt or confuse incoming missiles using electronic signals. While details of such systems remain classified, their goal was simple: interfere with the missile's ability to accurately track its target. Even a small disruption could cause the weapon to deviate from its intended path in the complex environment of modern naval warfare. Electronic systems played a critical role alongside traditional weapons. Global monitoring. Meanwhile, the situation was being watched far beyond the fleet itself. Same data. The appearance of hypersonic missiles near a carrier strike group represented a potentially serious escalation. Diplomatic channels began quietly preparing responses. Public statements were drafted, but for the moment, everyone waited to see how the situation would unfold. The narrow margin. Back aboard the carrier, radar operators continued tracking the objects. Their screens displayed rapidly updating numbers, distance, velocity, estimated trajectory. Every update slightly adjusted the predicted outcome. This constant recalculation demonstrated the complexity of modern defense systems. Thousands of computations occurred every second. Yet, despite all that technology, the situation still depended on human judgment. Commanders needed to decide how to respond, and they had to do it quickly. Strategic awareness. Beyond the immediate tactical situation, commanders also considered the broader strategic picture. Aircraft carriers represent one of the most visible symbols of naval power. Their presence in international waters sends a message about influence, alliances, and deterrence. Any threat directed at such a vessel carries enormous political significance. That is why encounters like this are treated with extreme caution. Decisions made in moments of tension can shape international relationships for years. Precision tracking, radar systems continue refining their tracking data. The destroyers surrounding the carrier coordinated their sensors, sharing information through secure networks. This cooperative tracking allowed the fleet to create a more accurate picture of the situation. Each ship contributed its own data. Together, the combined system provided far greater awareness than any single vessel could achieve alone. This work defense capability represents one of the most important developments in modern naval operations. The role of training. While advanced technology plays a critical role, the human factor remains just as important. The sailors working inside the Combat Information Center had spent years preparing for high-pressure situations. Simulators, drills, and exercises were designed to mimic exactly this kind of scenario. Those preparations allowed them to stay focused despite the tension. In military operations, discipline and training often determine whether a situation escalates or stabilizes.